In part 2 of this series, I was working on the aluminum pieces, but in the background there was a piece of keystock that was stainless steel. Here it is, 1/4 inch, and with my magnet I touch it to verify. And welcome to part 4.
So this next piece, we don't have any 1/8 inch stainless steel keystock, so I have to take a piece of 1/4 inch, mill down one side, and then rotate it 90, mill down the other side. But as I was saying, with the aluminum piece, I don't want to mill down too much at once because this piece will actually warp and it'll end up being slightly curved. Now the other thing, so I'll just be taking light cuts, and the other thing is usually you would stack up parallel on each side, but these parallels are actually 1/8 of an inch thick each, or maybe just a hair over. So I have almost the height that I need. I need to actually adjust a little bit more. But when I go to tighten up the vise, as you can see, my piece still moves because with the parallels side by side, it's actually the vise is clamping onto the parallels and not quite on my 1/4 inch stainless steel keystock. So the solution here is to loosen it up and simply take out one set of parallels and keep a set in there. If you can't grab it, you can take one, stick it on the other side, push that one out, rather than taking the vise all the way back out. So now, I tighten it up. My piece is actually tight in there now on the one set of parallels. And we have this kit we have, not a label or anything, but it has parallels all the way from 1/2 inch and then in 1/8 of an inch increments, 5/8, 3/4, etc., all the way up to 1 5/8 inches. So I should be able to come up with some combination, and if I need to get something a 1/16 higher or lower, then I could just grab a piece of whatever flat piece of material that's real thin that I can find to add to the parallels to get my material to stick up just enough to mill down however much I'm trying to mill down.
And now I will smack the keystock in the vise with a soft hammer so that it sits flat against the parallel. And then I'll push on the parallel with my scale just to verify that the parallels are tight in the setup there. So now I'm taking a 1/2 inch end mill so I can straddle both sides of the material that I'm running the end mill over top of. And I'm just going to take light cuts because it's stainless, and also because it's stainless, I am going to run the coolant system so that there's coolant spraying on to the end mill as I'm running the end mill down the length of the material, because the end mill will get hot, and we want to make sure that the end mill lasts as long as it can, hence the coolant. And the coolant, because it has some air pressure behind it, it also helps blow the chips out somewhat, but I still have the air hose with the air gun attached to it blowing the chips out as I go along making the cut. So making 20 thousandths passes, and then once I get a little more confident, taking 30 thousandths off at a time, I go along milling my piece of 1/4 inch keystock down, not quite down to 1/8 of an inch, but down more like 155 thousandths of an inch, which you will see towards the end of the video. I'll measure it with the 0 to 1 mics. But my theory is I can mill off about 20 thousandths at a time instead of taking the whole, let's say 90 thousandths off, to get down to my final size, because like I said before, I've had it warp on me. So I want to avoid that if possible by just taking light cuts.
Another thing you can do when you're grabbing a piece, barely by a 1/16 of it, is you can stick a little bit out the end of the vise. You could take a measurement, a 1/16 of an inch sticking out, and then as you mill on it, take a cut on the next pass. Before you take the next pass, measure if any more sticking out, you know your piece moved in the vise.
And my theory was wrong. It warped. It slightly curved. It popped out when I loosened up the vise. And as you can see, any side I lay it on, it's curved on either end or in the middle, depending on which side I lay it on. But I milled that side down to 155 thousandths of an inch, which is a little bit less than 3/16 of an inch, which will work out for how it'll mate to the other aluminum pieces that I'm also milling. So I turned it 90 degrees, put it back in the vise, and again, I'm only grabbing about a 1/16 of it towards on the bottom. But I turned it 90 degrees so I can mill this side down to around about the same 155 thousandths, because again, we're starting at 250 thousandths. And I'm just making light cuts, but even though I'm making light cuts, it's still causing, the piece ends up being warped. And you see, as I loosen it here, it just pops right out, because it has a memory in the material now. And because I was only grabbing on such a small section and I milled off the top that wasn't being, clamped down on, caused it to warp and pop right out of the vise. So going back to my part 2 video, bolting down your material and then milling off the top of it is the better way. It's just a superior way. So here, I'm just gonna experiment. I'm gonna try putting shims in at different spots while clamping the material down in the vise and tightening it as hard as I can, in the hopes that I could try to bend it back straight. But the problem here is that the material is still too thick for that. I've had a piece of slightly bent 1/16 of an inch thick or less pieces of material before, and those are thin enough where if I put them in a vise, I can clamp down on the vise hard and straighten thin pieces of material like that back out from being bent back to straight. But unfortunately here, because this material is a little over 1/8 of an inch thick, it's just not going to work. It's simply not. Maybe if it was a softer material like aluminum, it could possibly work. I could see that maybe working, but here, because it's stainless, it's harder than aluminum, it's just not going to work. So I'll just have to roll out with it. I'm going to be cutting this piece of stainless in the 4s anyways, so because it has a slight curve to it, it shouldn't be that big of a deal. But just to double check on my sizing, I'm going to take measurements at 3 different points along the length of the material, and I'll turn it 90 and do the same thing. So as you can see right there, I have 162 thousandths, about halfway down the length of the material. I started out at 156, and then all the way towards the other end of this 6-inch piece of stainless, I'm also looking at, I think, about 162 thousandths of an inch. So the middle and the end, I'm getting the same measurement, but towards the front, I'm getting about 6 thousandths smaller. So I'm thinking when I milled down the first side and then when I flipped it 90, because it was warped in the vise, even though I grabbed it and pushed down on it while I grabbed the material and tightened it in the vise, because it was warped, it was slightly curved up. So that is why on one side the thickness is off by just a little bit, because it wasn't sitting perfectly flat when I turned it 90. But again, it's close enough to where it'll meet up with my aluminum pieces and it'll work out for me just fine. So this has been milling down a piece of stainless steel Keystock. If we had an 1/8 inch piece of Keystock in the shop, I wouldn't have had to make this video. This would not have been part of the process. I was just showing you on either at the end of part 3 or before part 5, just cutting a piece of 1/8" keystock 3 times into 4 pieces. But alas, sometimes you just don't have the right size. See you.